This is lesson 5.4, bond enthalpies. So bond enthalpy is the energy needed to break 1 mole of bonds in gaseous molecules under standard conditions. Breaking bonds is endothermic, meaning that it requires energy. For example, in diatomic chlorine, to break that bond and form 2 chlorine atoms, you have to add 242 kilojoules. Let's talk about a case where we break more than one bond. In water, to break the first HO bond, it requires 502 kilojoules of energy. To break the second OH bond, it requires 472 kilojoules of energy. Well, that's weird that it takes more energy to break the first HO bond. You would think that they would both be the same. To break an OH bond in ethanol, it's even different. So what do? In order to find the bond enthalpy of an HO bond, we actually average all the bond enthalpies of the HO bonds that we know. So the average bond enthalpy is calculated using reactions in the gaseous state so that you can ignore intermolecular forces. And you have a chart that looks like this in your data booklet that lists the average bond enthalpies of some common bonds. To make a bond, it's exothermic, meaning that it releases energy. For example, 2 hydrogen atoms forming a diatomic hydrogen will release negative 436 kilojoules of energy. So to calculate energy changes using bond enthalpies, the first step is to write an equation. Then you'll draw a table which shows the bonds broken and the bonds formed and their energy changes. And then you'll subtract the moles times the bonds broken minus the moles times the enthalpy of the bonds being formed to find the total enthalpy change of the reaction. For example, in the combustion of methanol, methanol is CH3OH. If we add oxygen and we form carbon dioxide and water, the first thing we do is write a balanced equation, and then, so now we need to go back and balance it. The next thing that we need to do is draw Lewis dot diagrams for each molecule so that we know what bonds are being broken and which bonds are being formed. So we have 2 moles of methanol plus 3 moles of oxygen, and we have 2 moles of carbon dioxide and 4 moles of water. Now we can make our table of the bonds being broken and the bonds being formed. So we can see that we're going to break 3 CH bonds times 2 is 6 carbon-hydrogen bonds. Plus we have 2 CO bonds and 2 OH bonds. We're also going to make 3 oxygen-oxygen double bonds. Over here we're going to form 4 C double bond O's, 2 here times 2, plus 8 OH bonds, 2 here times 4. So if we look on our average bond enthalpy chart in our data booklet, we're going to list the enthalpy changes for each bond type being broken and formed multiplied by the moles. So 6 moles times 413, for example, for a carbon-hydrogen bond. Then we add these up, and subtract, and we get the delta H, which is negative 1080 kilojoules.